Whoa, bro, that's 2 pi. No, man, that was a 360. It's the same thing, man.
The other way is in radians. So this would be 2 pi, or 3.14 times 2. That gives us 6.2. The reason that there are two different forms is that radians gives you an accurate measure of the actual length, where degree does not give you that. So you might wonder how to go from degrees to radians. So if we had 180 degrees, we would multiply pi over 180 degrees equals, and that would give us pi. Same as if we went from radians, so pi, and we'd go multiply by 180 over pi, giving us 180 degrees. This normally would be 90 degrees, but in radian form, that would be pi over 2. And this would be 180 degrees, or pi, and this would be 270, or 3 pi over 2, giving us that. And this here would be 45 degrees, or I think it would be pi over 4. This would be 30 degrees, and pi over 6. Looking at this unit circle over here, we realize that this change in theta is pi over 6, and if we drop a line down here, this gives us a right angle triangle, giving us a 30, 60, 90 triangle. So from that, we can see that this would be 1, 2, and root 3. From here, we can look at cosine, which would give us, we would look at SOHCAHTOA, so SOHCAHTOA, which would give us opposite adjacent over hypotenuse, so A over H, giving us cos of adjacent, which is root 3 over our hypotenuse of 2, and sine would be opposite over hypotenuse, or that gives us sine of 1 over 2. Now we would take our coordinates, which now we have as root 3 over 2 and 1 over 2. If we wanted to graph our new function here, we would take the sine of that, which would give us, it's called the wrapping theory. If we graphed it, it would give us, our sine would look like this, and our cosine would look like that. Starting our cosine at 1 and our sine at 0. Our reciprocals of this, our first trigonometric ratio here is tan. Our second is cos, starting at 1, goes down to 0, then down to -1, then back to 0, and over to 1. Cos is an even function because it has symmetry in the y-axis, and graphically you can see that. And if we look here, then algebraically it's f of x minus x equals f of x. So we can see symmetry in the axis, or in the axis here. And then here's our sine function, which starts at 0 and then goes up to 1, down to 0, and then to -1 and back to 0. Our reciprocal functions are 1 over tan, which is cot, and we can see here cot, the reciprocal. And then our second is 1 over cos, giving us CSC. And for this, our asymptotes are where y equals 0. And if we look here, y equals 0 there. So our functions are shown off of that, which you can't have them going through 0. And then our last function is 1 over sine giving us CSC, where our asymptotes again cannot be at 0. So we draw a line up through there.